Thank you for tuning in to This Automation Life, brought to you by Brenner-Fiedler. I'm your host, Jeremy Schubert. Each week we discuss technologies used in automation. This week, Paul Oppenheim, sensor and control specialist with Brenner-Fiedler, is here to discuss lasers. Thanks for joining us, Paul.
Excellent. It's great to be here again.
Yes.
Excellent.
Lasers. So I think the first thing everybody thinks of with lasers is either burning holes in steel or shark's heads. What do we talk about when we're talking about laser sensors?
Okay. Well, when we're referring to laser sensors, we're actually referring to a very small beam spot that can be projected onto a target that you're looking for. So normally, I think when we have to kind of take a step back and first get into the why and how does this compare to other sensors? Maybe
Yeah.
we talked about. Okay. Yeah.
So versus usually a laser is compared to like a regular photoelectric sensor.
Great.
So
okay. So
what's the norm, and then why a laser?
excellent. Okay. So what we're not talking about normally right now is, let's say, for instance, like a diffuse reflective type sensor.
Yeah.
Okay, great. So the most common type of photoelectric sensor is an LED style light emitting diode.
Okay.
Now, I usually try to use analogies to kind of help get my point across. So if you can think of, let's say, like a flashlight, you shoot that against a wall, and it's fairly close to the wall, you'll see that, let's say, the diameter of that light is probably about the same size as the actual casing itself. It's only light. Then if you start backing that slowly away from the wall, you'll see that that beam does what?
It gets bigger.
It gets pretty big, pretty fast, right?
Yes. Yeah.
Okay. And you'll also notice that the intensity of that light gets a lot fader, or it starts to fade a bit too. Okay,
Yeah.
it starts to disperse over that area. Well, when you're looking at a target, let's say, you have to always make sure that the target that you're looking at, or rather the light that's bouncing off the target, can be seen comfortably and it sees that entire target. So let's say, for instance, if your target was the size of, let's say, like a coffee mug, okay, and you had a photoelectric sensor, I could probably sense that coffee mug at a fairly decent distance with that photoelectric sensor, simply because that light that's coming out, the beam spot itself, even though it grows, it will still be contained, let's say, within, or you can see the majority of that beam reflected off of the coffee mug.
So there's enough surface area on a big object to reflect the light back to the photo.
Exactly.
Okay.
Right.
I gotcha.
Now, let's say we're not looking at a photo. I mean, we're not looking at a coffee cup anymore. We're looking at something.
Like a computer chip with pins on a computer chip.
A small little pin, or whatever the case. Exactly. Now the problem is that right from the get-go, you'll see that that little pin is almost dwarfed by the amount of light coming out of the photoelectric sensor, so that the majority of the light coming off that sensor just kind of shoots off into space, and hardly any is being reflected back off of that pin.
Okay.
Well, as a result, now my sensor is kind of useless because I can't even see that target. So what we need
useless sensor.
Exactly. Nobody wants a useless sensor. No. Okay, I want to rush that right back to the store and put that right back on the shelf.
Right back on Walmart's shelf.
That's it. Forget it. I'm not going to do this ever again. No, what we do is just that the wrong sensor was used. What you need to do now is, it would be great if we can somehow collimate that beam to a small, more of an infinitesimal or point.
That sounds great, but how do we do that?
That's where you use a laser sensor.
Whoa!
Hey, so coming back to what we were first talking about, yes, a laser sensor is used for, as you probably kind of surmised by now, detecting tiny targets.
Okay.
And also at a distance as well.
Okay.
Some other advantages where a laser sensor is better than a photoelectric sensor as well is, even if the target, it can be even a bigger size, but let's say for whatever reason the environment that the sensor is exposed to, or rather that the target is in, there might be some swinging robotic arms or something like that, where the photoelectric sensor might be susceptible to getting smacked around. It'd be nice to have that sensor kind of remote, perhaps, away from the target.
Yes.
Okay, excellent. So with a laser sensor, because you're collimating all that energy into a small single point, you can get some fairly decent detecting distance. So I can actually have that sensor maybe a good foot, maybe 3 feet away from the target, out of harm's way, so to speak, but can still detect that target coming by.
Okay. So what I'm thinking of is, even though we may be detecting this coffee mug that the robot is drinking out of, or whatever it's doing with this coffee mug, we can be far away and still see the coffee mug, because with a regular photo eye, we'd see the arm, the robot's arm, and the coffee mug.
Correct.
Okay.
Exactly.
I get it. So small parts or small parts in relation to your distance, I guess.
Right. Or even if they're even slightly larger parts, again, with that collimated beam, you're more guaranteed to see that at a longer distance. Whereas even a photoelectric sensor, perhaps 3 feet away, again, you might still have that problem where a lot of that light now is spread over too big an area, and it's just kind of shooting off into space, and not enough is reflecting off the target because you're so far away.
I gotcha. But now, what about, what if I needed to look down a little tube, like a small tube, to see a part on the other end of it? Is there a way to do that with a laser?
Sure. If you're, again, doing this diffuse approach, yes, that's excellent for that. The thing you have to look out for is you have to make sure, though, that the laser can make it back to the receiver.
Okay.
Okay, so that's something you have to, and usually what you use is, I think that the term is they use what's called a coaxial type laser
that
sensor.
makes sense. Yep.
Right, so that the light can actually make it all the way down that shaft and come back through that shaft as well.
Okay.
So there are specially designed lasers for that.
Okay.
Okay.
Cool. I can't think of a reason to use that right now, but someday I'm sure there's somebody that needs it.
Okay. Well, very good.
What about positioning? Is that ever, I mean, if you got a smaller spot, is it more useful if you're trying to, let's say, move something into a location?
Yeah, absolutely. Because again, because you have such a small beam spot, seeing the leading or trailing edge of a target is much easier to do than with a photoelectric sensor.
So maybe like indexing parts into place or registering a part off of a notch, maybe better for a laser.
Sure, absolutely.
Okay. Now we talked about them being diffuse. Are there? I mean, are lasers available in like all the styles that a photoelectric is available?
Most companies do have it in all different styles too,
Okay.
as a retroreflective and as a through beam as well.
Okay.
Correct.
Cool. So through beam, reflective, retroreflective. So you've got a reflector there.
Right.
All of it.
Okay.
Cool.
So then the only thing now would be like, well, gosh, now that laser sounds like the best way to go, why would I ever use a regular photoelectric sensor?
Good point.
Mostly cost at that point.
Okay.
An LED light emitting diode, you're looking at a sensor, you're probably looking more of maybe $50 to $80 range, whereas with a laser, you're probably starting at maybe around $250 to $300 range and going in from there.
Okay.
So if you don't necessarily need precision, if you don't need to have, or you're not in those situations that are a bit unique where you need to have the sensor remote far away, or your target's very tiny, perhaps a regular photoelectric sensor would be perfect.
Okay. Cool. Well, I think that's a good. I feel like I know a lot about it now.
Excellent.
So that's good. I hope everybody else does. But that's all the time we have for this week.
Okay.
Paul, thanks for coming in
Sure.
again. And thanks everybody for listening to Brenner-Fiedler's This Automation Life. Be sure to continue tuning in each week. We've got some more episodes coming up. I think we're going to look at some more sensors. Going to start getting into motion control. It's going to be a blast.